Hello, everyone. Hello, Frank. How are you
Hello,
doing?
how are you?
So far, so good. So far, so good. We celebrated Halloween yesterday, and our street was busy with kids and adults walking around, taking candies. So that was fun, and that was the first time when I was giving away, some stuff because usually you take kids and you just go around your community, you pick up stuff, you do boo,
Yes.
all that matters. But this year I decided, right, let me experiment this from the other side. I just, bought a huge pack of candies and I dressed up as a pirate and I liked it. I liked it. How about you? Did you guys celebrate Halloween as in
Yeah,
Europe?
yeah, it's basically the same. Kids are ringing at the door, and you
Uh,
need to have something, and when you don't have any more, you just put you can just write nothing else. If not, they will continue to ring all the night.
yeah, stay away, kind of right. The stay away message. I ran
Yeah,
out of full. Yeah, just no more candies. Sorry. Yeah, it's interesting because yeah, it definitely depends because we live in this community with single family houses, which mean that eventually, if a family that lives in house A is ready just to take part in this celebration, they just get on the street, they put a table or whatever, and they just nobody knocks the door. But yeah, historically, when that was studied, like yeah, kids would go, they would knock the door, some would open, some would not.
yeah,
But yeah, in our community, it was like more like everyone is on the street, someone is giving away, someone is just looking around. That was fun.
it's
All right.
organized.
Yeah. Yeah.
Okay, so if people in the chat can say hello to be sure that we are live on Twitter, LinkedIn, Twitch, YouTube.
Yep, yep, everywhere. And yes, hello everyone. Welcome to our next episode of the Community Open Hours. That's the 12th episode. We are doing this bi-weekly. Tell us, like, how was your yesterday? Did you folks celebrate Halloween as well? Because we know that this holiday became quite international and celebrated abroad. Just say hi, say how's it going, and say what what are you expecting to learn from this session? Because today's session is about AI, about artificial intelligence, and exactly how to use YugabyteDB to build scalable AI applications, because we released the first early version for the pgvector extension that allows you to store vectors embeddings in your YugabyteDB cluster and then run, similarity search and other calculations over this data. But before that, we have highlights, right? We always want to start with highlights, with something that happened throughout the last 2 weeks in the world of YugabyteDB. So, Frank, what's happening? Like, what any interesting questions you
Yeah,
came across?
there is a question we have very often, and it's what is the fastest way to count rows in a table? And when I have this question, I always ask, why do you want to count the rows? Because um, there is not a lot of business cases where you really want to count all rows in a table. And if there is one, then probably you will implement some counters because counting rows is basically reading all rows and then counting them. But there are some reasons to do that just to get an idea about the number of rows or to compare, for example, when you replicate between two databases or just to compare. And also we had a support note to with a way to run in small chunks in parallels. But what I can show you today, because I've written a blog post about it, we don't really need to do that anymore because it is parallelized already. Let me share
Mhm.
my screen for 2 minutes and I
So,
will show you the idea. So the blog post is just fast select count, but my idea is just to show how it works by looking at the execution plan. Because if you want to see if something is optimal or not, you need to look at the execution plan. So first, I just count, and I see it takes 1 second to count my 11 million rows there. If I look at the execution plan, I can also already see some optimization. Let me just put that smaller because
mhm.
I did the big execution plan there, even smaller maybe. I did the big one that we have in the latest version with dist that shows the number of tables, table reads, read request, but also debug that shows a lot of metrics which I like, the RocksDB metrics that are in behind. But basically, the optimization are partial aggregate in each tablet. Here I have 3 tablets. I see 3, 6, which means that I read from 3 tablets and then I read all the rows there. But this happens in the storage within one single read request. And this is why it's fast. It still reads all rows, as we can see there, but it doesn't have to send all rows to the network, just the partial count from the 3 tablets here.
So, question for you, like, yeah, just to tell this from my perspective. So, like, you have this SQL session open to a 3-node YugabyteDB cluster. So eventually, when you run this request, the request goes to the query layer, to our Postgres backend, right? That's effectively Postgres. But then Postgres, you don't want to bring all the data from your storage layer that is stored in our tablets, right, to the Postgres layer, because it's excessive data movement. And this is what this execution plan shows, right? That the request went to Postgres backend, and the Postgres backend eventually sent this request to the storage layer, to DuckDB, and we use RocksDB internally on the storage layer. That's why you have RocksDB mentioned here many times.
Yeah.
But the question for you, like, you have a 3-node cluster. Is this a collocated table? Because why do I have just 1 read request to the storage? Why don't I see 3 read requests to all of the cluster nodes?
That's a really good question. Actually, the read requests are not exactly the number of RPCs. The thing is, this read request will run 3 in parallel. That's what I understood from our latest implementation between the SQL layer and the storage layer. This is 1 read request where there are 3 reads to each tablet. So we can see the 3, 6 there, but we have 3 RPCs because it goes to 3 nodes. I don't think there is exactly this metric there, but because it runs in parallel, it's only 1 read request here. So maybe the term read request is not really exact because it's, it depends on the layer. There is a level where it is run in parallel, so there are multiple ones.
Okay.
So that's one additional optimization. Partial aggregate is one, and parallelization, because if you have a lot of tablets, you want the count to be done on each tablet and at the same time. So that's finally you get all the results at the same time. Yeah.
And could you, like in Postgres also, you did what did you did the count star, correct?
Yeah.
And so that many still think that when you do count star means that their database will pick all the will read all the columns for a row. But in Postgres, usually it's possible to see that that's not the case. If you run,
you want me to add 1 verbose?
Yeah, let's do verbose, and probably you can turn on costs. Let's see what happens. There is a special column called width.
Oh, okay. Yeah.
It goes usually, do the costs on, and
I disabled cost that is there by default just because it's long output. But
here it is. You see this? It says width. Not the other one where you have the sequential scan. What happens on the storage layer? Width is set to 0, which means that on the storage layer, we just iterating those millions of rows, and we are not checking all those columns. So it doesn't matter how many columns you have. It's safe to do count star if you need it, but just don't, as Frank said, don't do this frequently. Don't abuse this functionality. Only once in a while, if you need to count this, do this. And it's safe to do count star, not count 1 or anything else.
Yeah, and maybe just one more thing. Sometimes you don't need the exact count. You can have an approximate count, because anyway, if there are concurrent inserts, you will have a snapshot of it, but it changes. So if you don't need the exact count, but you just want to have an idea about the number of rows, there is something that we can do. Just because my table is hash sharded, let me show maybe the schema. So I have the primary key that is ID, and it is hash sharded. And then I can count only from one shard. The hash code goes from 0 to 65535. So I can count from only one shard and then multiply it to get the approximate count. So for example, if I multiply it, I count only one shard, so this is really fast, and I multiply it. And because it is assured, it is well distributed, and I have an approximate count that is quite correct. So that's also a solution. If the goal is just to know if you have 1 or 10 million of rows, you don't need the exact number, and the table is assured, which is usually the case for big tables. Then you can just count from 1, and then you have an idea.
All right. Yeah. Like while you were explaining, that's a good example. I mean, especially if you have some condition, then you would also minimize, right, this number of calculations. Let me. I've already shared your blog post and the video about count star and count one that I produced in other databases. That's for those who would like to learn more. Let me also share this in here so that the folks from YouTube, Twitch, and Twitter can see it. Just sorry for a short pause.
But the main point usually is asking why we want to count the rows. Because if it's a business requirement, for example, to know exactly how many users connected per day or something like that, maybe it's much easier to maintain a counter from a trigger or from the application rather than counting all the rows.
Yeah. And here is a remark from Pete. Yeah, welcome, Pete. Thanks for joining us. AI, I am expecting this to be the last instruction I need to run Yugabyte or any AI system. System can learn to run itself. Yeah, like we are not there yet, but yeah, Pete. We are going to talk about pgvector. You certainly know pgvector and you heard about it, probably used it, and we just want to build some scalable application, just a simple application from scratch using this feature that was introduced in YugabyteDB. Okay, so to wrap things up, so folks, you will find the link to the Franck's article in the chat, where you are, depending on your location, YouTube or LinkedIn or Twitter, etc. And also there, I shared with you what I shared with you. I shared with you another video because, and this is just educational, if you're interested in databases, in other databases, let me go and show how.
Yeah, about what you mentioned about count star versus count one, and SQL is supposed to be standard, and count star is in the standard, but the execution plan is different in all databases.
Yeah, so and that video shows you so that it's okay to use count star at least in 4 like major databases according to DBGenS and Oracle, in Postgres, in MySQL, and in SQL Server, and also in YugabyteDB, as Franck showed. Just take a look at the difference.
I think that no database will really take the star as and read all columns to count finally the number of rows. The only thing that may be different in some databases, for example, when you do a count star, you don't have to read the table. If you have an index, for example, a primary key, maybe the index on the primary key is smaller, and you can count from there, or even another index, but that depends on databases. For example, in Oracle doesn't index the null values. And then if you do a count star, not all indexes can give you the count. Because if you have an index on a nullable column, it cannot get the count for it. So there are some difference in some databases for indexing. Yeah.
Exactly. So the first, we already spent a lot of time with you discussing this count star dilemma, but what I also wanted to show you what happened, a quick highlight for you folks who are following YugabyteDB, using YugabyteDB, is Eventually, we can publicly talk about one of their top tier, top one services that also runs in YugabyteDB, Paramount Plus. It's like, at least I don't know how popular it is in Europe, but it's getting traction in the United States. It's like we have Netflix, certainly we have Paramount Plus, we have a few other players, but this one is very visible. And why it's visible? Because also in the United States, folks are obsessed about football, I mean American football, about baseball, and Paramount Plus streams their stuff, meaning that all those shows that get a tsunami of traffic, they're being streamed on this platform. And these days, it's like this platform is running. It's a multi-region. It runs, and the guys just told the high level story. Eventually, they were running in Google, in one single Google region. And their application layer was already ready for the multi-region deployment because their application instances were running across several availability zones for high availability, for latency, etc. But they had one issue. They had the problem with the transactional database, with their system of records. It was MySQL. It was designed for we know that it's designed for single server deployments. There are several approaches how you can make it running multi-regions, but those are complicated and might be error prone. That's why they explored distributed relational databases. They picked YugabyteDB and right now they're running a stretched cluster across several regions in Google, and they're happy, and I think that they released this, they switched to this deployment not long ago, right? And
yeah, I think they switched a few months ago, and they started on it 1 year. What is really nice, we have a lot of big customers like that because, of course, they need to scale, but a lot of them we just cannot mention the name. So it's always really nice when they have a technical team that blogs about it, and then when people ask about customer using it in production, it's always better to link to the blog of those customers rather than marketing content where sometimes we cannot mention the customers. So yeah, that's really nice.
Exactly. So let's move forward. Oh, I was streaming like how I answering questions on LinkedIn. Now you folks know how we answer questions on LinkedIn. It's easy. You just copy and paste your answer. All right. We are multitasking here. So we have 40 minutes left for this show, and let's go straight to our main topic, to the pgvector, to YugabyteDB, and to AI applications. So, Franck, I remember that, if I'm not mistaken, you recently went to one of the conferences and you took part in a panel discussion about the AI for developers.
Yeah, exactly. Yeah, it was really interesting because not only technical problems, but ethical problems were raised. It was really interesting because it was a conference in Bucharest, in Romania, organized by a hiring company. It was so a lot of juniors in IT, and yeah, they think about the future of those technology in different ways, and was really interesting. And of course, databases have something to do there because AI needs to store and query a lot of data. And this is the idea of pgvector.
And financially, I mean, like, personally, like everyone has different views on this AI. There is certainly right now we are certainly in the hype cycle. When it goes way too high, then it's going to be stabilized. But I think that once it declines a little bit, some of the companies will disappear, but the AI is here to stay, because even these days, OpenAI is already a very profitable business. They announced their last quarter report. Azure also owns a half of OpenAI, and they have their own version for their AI. Like GitHub Copilot that belongs to Microsoft also is one of the most successful financial products. It's mean like the AI use cases are growing tremendously. So let's talk about YugabyteDB. So, and today I want us folks to build some sample application. So what the sample application? Why I clicked in the wrong. Let me fix my. That's the sample application. So let's say that you're traveling to San Francisco in California, and you're searching. You want to find the best place to stay, some hotel or Airbnb property, and our application, our service will be doing that. You open the UI, you type in your prompt, you want to stay in San Francisco near the Golden Gate Bridge, blah, blah, blah. And then the application will support two modes. The first mode is called OpenAI chat mode. And in this OpenAI chat mode, we are going to connect to the OpenAI. Yeah, this one is for Azure, but we can open, yeah, let's open this one, another picture. We are going to connect to the OpenAI API and to get the recommendations, because the way you interact with ChatGPT through the chat interface, you can interact with this GPT model programmatically from your application code. We will show it to you. By the way, Frank, how frequently do you use ChatGPT?
I use it mostly for checking my English when writing blog posts, but now I tested Grammarly from your recommendation, and I think that for this purpose, Grammarly is doing much better. I mean, correcting the grammar and the spelling without changing too much my words. So yeah, a bit less using ChatGPT now, but for code, sometimes I want to test something with code, with languages that I don't really know a lot. It can help also. Yeah.
Yeah, that's actually for me also, as a non-English speaker, not native English speaker. It's also a big deal, because I no longer see a big value in Grammarly. Probably they need just to level up their value for the users like me. And yeah, like Copilot, actually, I will show you folks today how I started using Copilot. Sometimes it's right, sometimes it's utterly wrong. It's all about, let's say, the latest information it was trained on. All right, that's going to be the first mode. Basically, we'll take the user prompt as is, and we will send it to this GPT model somewhere in the internet, and we will get the result back. The second mode, and we will see that this mode is slow. It literally would be taking 10, 15, or 20 seconds to get that result back, because this model is huge, it's generic, and it's being used by probably millions and millions of people.
And you have to pay for it also. You have a token and you have credits to use it.
I pay. I mean, like, it's say I put down $10 a couple of months ago, and I still use it. It's if let's say if you use this certainly for your high load application when you have thousands of visits then yeah, like it's your bill is going to grow. But if you just want to create something, you're a startup, right? You're a startup, you're building some new cool service, etc. No, it's your bill is going to be small. It's not that expensive. And the second, but still, if you want to make things faster, for the Postgres embeddings mode, we will be stored. I call them Postgres because I mean I treat YugabyteDB as a distributed Postgres, which means that this application by definition works with both Postgres and YugabyteDB, and we will be looking at both modes. In this mode, what's going to happen? We will take this user prompt. We will send this user prompt to the OpenAI API, but to the embeddings model, and that embeddings model will generate a vectorized representation for the user prompt. And those of you folks who don't know what a vectorized representation is, imagine a large array of floating point numbers, just some numbers, and OpenAI generates a 1536 dimensional array. So like for every prompt, you're going to get this array big as a response, and then you're going to compare this array of floating point numbers against the floating point numbers stored in YugabyteDB on Postgres. What do we store in YugabyteDB? I found a sample data set for Airbnb properties. And every Airbnb property, as you will see, folks, it has description. And you can convert those descriptions. You can also use OpenAI API to convert all those descriptions to the embeddings. And then when you do the search, you're comparing the embeddings of those Airbnb properties to the embedding of the user prompt. It's simple. So let's see how it works. Yep. Time to go. So this application should be somewhere here. Let me go to my downloads folder. It's certainly in the temp directory, and you can do, let's open it in Visual Studio. As Frank said, there is no any free cookie in this world until at least even with OpenAI. So what I have in this application, I need to provide my OpenAI API key. So it's like this. And by default, the application is going to connect Postgres. I have this Postgres running. Let's take a look to my deployment, I have several databases. Postgres should be running in Docker. Yeah, it's running in Docker. Let me refresh this. That's my Airbnb listings table.
You are still sharing only
Come
the
on.
GitHub.
Seriously? Oh, come on. Thanks. Let's fix this.
At the beginning, I thought you did it on purpose so that we don't see your token.
No. I just forgot. Yeah, I need to share the entire screen. Yeah, that's what we need to do. Looking good now, right? So
Yeah.
that's my Postgres database. So what I have in Postgres, here is this Airbnb listings table. And this table comes with 107 columns. One of those columns was added by me. I added this column to the database. It's called description embedding. So let's take a look why. Let's select name, description, and description embedding from Airbnb listing property. Let's select the first three. And here, as you can see, that's the name of this property in San Francisco. You know, nice, very long description: location, amenities, neighborhood, and blah blah blah. Do you need a refrigerator, hair dryer, or whatever? And then what I did, I took every description for every property and I generated these embeddings using the OpenAI embedded API. I have the source code for this embeddings generator in this GitHub repository, and we will be using it today.
So this list of number is the translation, the mathematical translation of the meaning of the sentence in the description.
Exactly. This is like how the OpenAI
Yeah.
embeddings model sees this, and it basically. And one important aspect, when they will be translating a user prompt into an embedding, we have to use the same model that was used for the generation of these embeddings. That's an obvious requirement. So it's here, and how is it possible to store this, right? And and we need to run similarity search. We would need to compare the distance between these embeddings and the embeddings for our user prompt. And that happens thanks to their extension that we already know, PG extensions, right? Extension.
Maybe I can mention something because in Postgres, we have vectors because we have arrays and there are some functions to compare them. The big difference is that here we have vectors with thousands of dimensions, and that doesn't work with the usual, the normal arrays that are in Postgres, and this is why we need something else.
Exactly. You need to optimize, and we have this PG extension installed for Postgres. It's here. And let's go to YugabyteDB because first we will test this for Postgres, and then let's say, obviously, whenever you need YugabyteDB, usually you think about scale, high availability, etc. I have the same table here in YugabyteDB, and if you run the same query against YugabyteDB, it's a 3-node cluster running in Docker. It's the same data. It's all the same. It was generated, and YugabyteDB also has this extension. pgvector extension installed. It's here. It's ready. So which means that once you create this version of application for Postgres, it should fly normally for YugabyteDB. Looks good, Frank. Shall we code?
And we see the extension version. That's the version number of the pgvector for Postgres. And if there is something to change on YugabyteDB, then we add the YugabyteDB version. Like with YugabyteDB, you have the Postgres version and the YugabyteDB version.
Exactly. That's a good remark. We don't just also as at the time of this recording, folks, when you will be watching us on demand, we still do not support any indexes for this extension, but it's coming. It's already planned. We are just deciding what's the best way to support this indexing across a distributed database. It's not that straightforward as it was for Postgres or any other single server database.
The thing is, there are many different kind of indexes, and we need to think about what is the best one, and also one that can evolve. You don't want to build new code for each kind of index. So probably we will do something that can help for different kind of indexes. For example, we don't have GIST indexes yet, and they are a bit similar. So yeah, maybe we will implement that. But I've seen also that we have an open source contributor who already was looking at implementing those indexes.
Yeah, exactly. And that's so we don't want to rush, right? We eventually decided to release this extension because there was so many inquiries. So we released it, and right now we have it on our roadmap, and we daily working on it, just deciding what's going to be the best way to support this. And we have time, I would say. We have time for this. But we can already play with it. So let's go to our application. So we are connected by default to Postgres, but our first version is not going to use Postgres at all. As you remember, I want the first version of the application to use GPT model, Generative Predefined Transformer Model. This is what it stands for. So let me start the backend of this application. This is a Node.js application, folks. I kind of classify myself as a Java developer, but I think that JavaScript might be, it's quite more universal. Like if you code in Python, Java, JavaScript, Node.js, you would be able to understand the source code. It's easy to read. So let's do this in JavaScript. Just starting the front end as well. I want to show you the UI, this beautiful UI, and I need your feedback, Frank. How do you like this UI? So the UI is here. So generally, that's the OpenAI chat mode, and this is Postgres embeddings mode. Let's start with the OpenAI mode. Let's say that we are traveling. We know that we are traveling to San Francisco, and let's say that I want to stay near the Golden Gate Bridge with a nice view of the bay. Frank, any requirements from you? What type of property do you want? You need parking. You need McDonald's.
I want that it's calm, not too
All right.
noisy.
Yeah, has to be calm and cozy neighborhood. Always spell folks near. Anyway, I messed up, I think. You'll understand it. And if you search right now, you can see this Pacman, nothing happening because the logic is not implemented. We need to implement it. So let's quickly implement it. Here is the skeleton, I think. Yeah, OpenAI chat mode. So we have connected to the OpenAI API using my API key. And this is the method search places that we need to implement. Here is the user prompt that I typed in here. Okay. So how do we implement it? It's easy. Let's get GPT response. The name of the interface is chat completion. This is actually, I'm using Copilot, but the Copilot, I think, doesn't have the latest information on the API of their OpenAI IP. That's why it's going to misguide me from time to time. But this is, yeah, OpenAI chat completions create. You need to create the message, and that's JavaScript, and actually the API is JSON based. The first one of the objects is going to be messages, and you need to pass an array of messages. System OpenAI system message. So one of the messages is the system message, and this system message is not visible to the user. So here is you as a developer. You tell the model what the model needs to do, what's expected from this model. And I'm telling, hey, you're a helpful assistant. Help to find people lodging in San Francisco. At least suggest 3 options and send back a JSON object in the following format. I need to know the name of the place, description, price, etc. And I'm just telling, don't send anything else because it's verbose. It usually says, oh, I think you wanted this. I'm telling, just send me JSON. This works for GPT-4. This doesn't work for GPT-3. It ignores you, and you need to parse JSON in the response. That's the system message. And the second message, you want to have role user. Yeah, it knows it. You see, Copilot works from time to time. The user message, and we are just passing the user prompt. And finally, you need to select the model. That's the second parameter. Let's use the greatest at the moment, GPT-4. So that's it. You're sending this request, REST request, REST API actually, and then we need to process it. What does it get? If my memory doesn't fail me, because it has choices. We will take choice number one, the first choice. Usually it sends in one, is a one choice, and then you have message, and then you have content. Probably I'm right. So that's what's gonna be returned, and we want to assign this to places JSON. Let's parse this to JSON. Let's see what's gonna happen.
Places.
Probably, yeah, places.
You have a typo here.
Places, yeah. So let's type it. Console log places, and then we're returning those places. So if everything that was simple, right? You just send this request. This is how you interact programmatically. That's the system message, and then you're converting this response back, and you're sending it to the UI. The UI of the application expects the JSON so that the places can be displayed. What we need to do, we need to restart the backend. Restart it.
What I find funny here is that with AI, you code with procedural language plus some text, a bit like you do with a database where you send SQL queries as text. So it's a mix of procedural and text and user input. Of course, with SQL, we know the problem of SQL injection. And here I already see some things for security to do, because you ingest the user input to your input, and then you must be sure that the user input cannot go into some side effects.
Yeah, that's true. That's true. But and also I am making this the responsibility of the OpenAI side, just to process this prompt, because I'm taking this one and sending it this. So eventually I was right. My memory didn't fail me, so we've got this response, right? This is what was suggested, and this is not just the Airbnb data. That's the whole information that is stored in GPT model is generic, and this is what they suggested. A couple of hotels, something is near Golden Gate Bridge, Fisherman Wharf, Marina District of San Francisco. This is a wonderful, Frank, you would love this district actually in San Francisco. This aligns with your prompt. But you remember, let's run this again. Just try to count. How much time does it take? It takes seconds, because first the request goes, then the model needs to process, because I think that there is a lot of traffic going to this model, and then it needs to respond. Okay, it takes time. It probably takes 15-20 seconds, and this is not what we want. We want to have a scalable application. So that's why we are going to implement the second mode, Postgres embedding. So YugabyteDB embeddings. This is what we discussed so far, right? We already have this embeddings stored in Postgres. Now, where are they? Select name, description embedding from Airbnb listing, limit 3. We have them stored, we have this data, we just need to implement the logic that would take the user prompt, translate this user prompt to their embedding, and run the similarity search, finding us the best place that meets the requirement of our prompt. So this logic needs to be here. I have this Postgres embeddings class. Here is, I'm connecting to the database. I'm using the PostgreSQL driver for Node.js. Here is my database connectivity settings. By default, I'm going to connect. I first will connect to Postgres that runs on in my Docker environment. So once connected, we also need to implement the same search places method. But here is we have, in addition to prompt that is taken as is from the interface, we have two other parameters. Matching threshold. It's like how similar the embedding of the user prompt needs to be to the embedding of an Airbnb description, over Airbnb place description. And this threshold is in the range between 0 and 1. So you just need to pick like it's usually like 0.7, 0.8, or whatever. And the matching count is like, how many suggestions do you want? We want 3. So I know that for this, it's coming from here. By default, our threshold will be, similarity threshold will be 0.7, and we want to get at least 3 recommendations.
So that's something you tune if you want more creativity or really stick to the prompt.
Yep, exactly. Yep. Yeah, the larger the better. Like the larger the more similar, meaning that it will. But also you kind of your prompt might be exotic, which means that you will find nothing. That's why there always needs to be the balance. You need to know like what your service does, what your users ask, and that's how you need to train your data. Now let's implement it. So we have this method, and this time we are not going to use the GPT model. We are going to use embeddings model. Let's call this embeddings response. For that, we also, that's an asynchronous operation. We are doing this. Yep, embeddings. Yeah, this one it remembers. It's called embeddings, but you miss this one. Create. This one is old. Yeah, Copilot needs to be retrained. It doesn't know the latest OpenAI API. So what you need to have, OpenAI embeddings, how it's called, embedding model. Yeah, the name of the model, the latest one, the best one is text embedding ADA 002. So this is how it's named, and then as the input, you just pass your prompt. That's it. That's your request. You take your prompt from the user, and you make this call to the OpenAI. And what you're going to get back, you're going to get that multi-dimensional array of floating point numbers that represents something for that.
So here you use an external service just to convert the text from the prompt to embeddings, but you don't need an external service to get the whole model.
Yeah, I mean, I'm using the OpenAI. Yeah, it's OpenAI. The OpenAI, the company that created ChatGPT. And here is, in our first version, we use the GPT model of OpenAI. It can be accessed programmatically. And here is, I'm using the embeddings model of the same company. So yeah, and I have this, my developer key. So I connect it to them. Once it's connected, so what we want to do, we need to run a SQL request. Okay, so let's do this. Let's do result. We have this, our client, and this is our SQL request. Not that trivial. First, we want to query from Airbnb listing, right? That's the name of the table. And what do we want to know? We certainly need the name of the property. We want to have description of the property. We want to have the price of the property. So let's do this.
Because now you have embeddings, but you have also some relational data because you have a list of description, price, and name for all the properties, in addition to the embeddings that are used to search for them.
Exactly, because for me, I mean, I have nothing against vectorized databases, but I think that eventually relational databases will be the driving force for these similarity searches, because usually it's not enough, just to have those embeddings into the similarity search. You also need to have some other data nearby, and that data needs to be updated. Transaction needs to be consistent, and and relational databases already provide these capabilities for you.
Yeah, it's like text search, where we search in the description, but then we want structured data for the results. Yeah.
Exactly. You know that. So here is, but we don't want everything, right? We want, let's finish this request properly. We want to calculate the distance. So we know that in the database, every Airbnb property place has description embedding column. And we want to calculate the distance between it and their first argument. The first argument is going to be this embedding that is generated by their OpenAI. And we want to do the cosine distance. Like this one is Euclidean distance. It's like when you have 2 points, let's say you have vector 2 points, and you just take a ruler and you measure the distance from point A to point B, like the way we measure stuff at school. And but the cosine distance is an angle like between different vectors, like, and depending on this angle value, like the database decides what's similar and what's not similar. And this one is suggested to use for the like for the use cases when you need to work with text models, with text searches. So that's why we use the cosine distance, and we want similarity. We just need to subtract this from, what's happening? Stop it. Stop it. Oh man, I know what's happening. Have you ever seen this?
There is something in your keyboard, or
Yep, something happened with my keyboard.
that's a demo effect that I've never seen before.
Wow. Wow. Come on. No, it's still. Let me.
Are you sure you didn't put your cup of coffee on the keyboard, or?
No. I detached my keyboard for now. Wow. That's a special effect. Now I need just to attach this keyboard back.
And
I
then
just
you
press
will
the
have.
button. Yep.
Okay.
All right. How do we clean this? We clean it this way.
Yeah.
You don't want to have any errors. All right. What can happen when you do the live coding?
And that's not Copilot.
No, I don't know. Yeah, it should not be. It should not be. All right, cleaning my code. So we calculating the similarity, and the similarity needs to be, let's say, bigger than the second parameter. The second parameter is going to be the matching threshold. Okay, and also we want to return. Let's return the similarity. I want to return the similarity. The similarity, and I want to order by similarity descending, like the closest,
makes sense,
most
yeah.
similar go first, and then you want to have limit 3, which like third argument that will be set to this one. So here is embeddings response. We have this embeddings response. Remember, our first argument is the embedding that was generated for the user prompt. It's in here. It's in data 0 embedding. I just remember it. And when you pass it to the database, you need to add this specifically. It's like this is what pgvector requires. And then, the other argument, this is our matching threshold. The distance, the similarity needs to be bigger than the matching threshold. It's 0.7, and that's our matching count. All right, this way we will get the results. Then, let's process every result. Here is, we have this places array. We want to push into this array. This is, you see, like this time, Copilot is very helpful. It basically takes every row from the result set, and it can recognize what I was requesting here. So next, but also it forgot about similarity. But you just can remind it. So this is what we are getting. So we connected to the embeddings model in the internet belonging to the OpenAI, the same company that created ChatGPT. We passed the user prompt, we generated the embedding for this user prompt, and then we are doing the similarity search within our Postgres database. We are searching for the Airbnb lodging options that are relevant for our user prompt. And then we are generating these places array in the JSON format. Okay. Let's see if it works. Because I restarted everything. I need to start my backend. It's quick. And let's start the front end. We go to the front end. And bring this as well. So now, do we have any prompt left? No, it's disappeared. Certainly disappeared. All right, let's do it this way. I have several prompts in here in the README. Yeah, let's copy this one. Let's run Postgres embeddings. Yeah, so there is an exception. That's fine. So let's see where I messed up. Yeah, because what I forgot to do is here. It says also asynchronous operation. You need to wait. You need to wait. It happens. So at least, folks, you understand that's a real coding session. Some stuff can fail and should fail. No, something else. It still complains about this result. What's wrong with this result? This client query. Now why do I need to wait here?
If people on the chat have ideas.
Let's do it this way. I think that, yeah, at first it saw that I was not using await. Now I'm using await. For row of result rows. Yeah, that's what we need to do.
So Copilot may help to generate code, but maybe not the best code.
Together with the Copilot, we will nail this. One more time. Let's see how many errors I'll get. Finally, you've got it.
Good.
So here is we've got some apartments, and if you search for Golden Gate, you have Golden Gate Bridge, and we have some deck. If you want, let's say, I want to stay near their Salesforce Tower in close proximity.
And this is querying a database. We know that there are some applications with multi-criteria screens to query a database, but here we are querying the database with plain English text.
Yep, that's what we are doing. And like here is another Salesforce Tower, and it's close to the Moscone Center, and and just see how quickly it happens. It's just a fraction of a second, and during this second, the fraction of a second, it's not just the database search. We went to this OpenAI embeddings model in the internet.
Yep.
It's much faster for them to generate just this vectorized representation, and then we queried our database, right? And these embeddings, like I told you that I generated these embeddings for the Airbnb descriptions beforehand. Here is the source code, and I used, when I was generating it, where is it? I was using the same model. The model is the same. The same model that I used for the prompt, I used it for the Airbnb descriptions. I was just, reading, and I was updating every table in the database, by updating the description for every row. That's what I was doing. Okay, so it was simple. But here is we're still using PostgreSQL. So what do we need to change if you want to use YugabyteDB? Because probably you need to use it. You need to use a distributed database from the scalability perspective and availability. So if we remember, we already know that this transition should be straightforward. I have YugabyteDB also running on my local laptop on this port number, and the database name is YugabyteDB. The username is Yugabyte, and the password is also YugabyteDB. Okay. So next, so what we are doing? What? 5 minutes. No. Okay, so we are restarting. We are restarting this. We are restarting the backend, and now when you run this, yeah, it opens the first connections to YugabyteDB, but generally, it is going to be comparable. So you have the same results.
Yeah,
that's it. That's how simple it is. Start with Postgres, switch to YugabyteDB, and just to show you one more time how we made this scalable. That was our first version with OpenAI ChatGPT and count, waiting, because it takes more time for that generic model to generate all this stuff. But if you have your own data set, if you know your business, if you know what your company does, what your product does, just find those descriptions in your whatever you're selling and generate it, stored in your database, because the speed will be much faster. It will be much faster. Okay,
And
cheaper.
for security also, you know exactly what you are querying, and it's your own database that has the data. You use an external service just for the prompt, for the user input, but the data stays in your database.
You're right, my friend. So let me share the final one. Is do we have any questions?
I
not now.
don't see any question.
Yeah, let me share the link to the repository with everyone. I will share the link. Yep, to this repository on LinkedIn and other places. So looks like that's it. That's how it works.
But that was very interesting, and this is where, because of course AI comes like a trend, and we don't know if it will stay or not. But when I see that you are just querying data with standard SQL, just with a different way from a prompt, but basically in Postgres, we have seen JSON and it is used. We have seen full text search and it is used. And I think that's just another kind of search in a database.
Yep, that's it. And what pgvector added, right? You saw those operators for the similarity search. It also, in addition, it does, as you said, it's not a big deal to store a vector in the database. It's a solved problem. The question is how to process this data efficiently. And pgvector added additional operators like the Euclidean distance calculation or cosine distance calculations. Those are new operators, and they exist in the same database that you already use for your other applications, right? You just use it probably for your financial application, for your logistic application, but right now you just.
And I didn't check, but I think it's even the same syntax as when you are looking for distance when you are using PostGIS, for example, for spatial, or it's basically it's a distance. Yeah.
Exactly. Yeah, actually,
it's a distance between points, just points within a lot of dimensions, but.
Because, but the more dimensions, the better usually. Because in OpenAI, the model that we use today, that model generates 1,536 dimensional array. I just even have hard time spelling this. There are some other models out there, like LangChain is very popular. Other models, usually a meaningful model comes with at least 300 dimensions or 600 dimensions. Most of the models like that I used have, like, say, 600 plus dimensions, but OpenAI is definitely one of the most powerful.
And then the next step is have indexes on it. And you mentioned that the indexes, we need to see how it is used to get the best implementation. There is also something, it's not data that is it's not static, but it's not too dynamic. For example, you load the information about the Airbnb maybe every day or every week, I don't know. So it's not the kind of index that has to be maintained in real time. It can be a bit asynchronous. If it can build a better index asynchronously, it's probably better than trying to do it real time. That's also something. I don't think we really need real time indexes for this kind of search. If you miss just the latest inserts, that's probably not a big deal. So yeah, there are different kind of indexing and balancing between the time to build the index and the time to query it.
Yeah, the index deserves a separate discussion because when it comes, as you said, when it comes to indexes for their vectorized data for these AI applications, it's also there is a trade-off between the accuracy, between the index build time, between the index maintenance time, because it can take sometimes hours if not days for you to build an index if you just want to have the best accurate response. But that will not work, and that's why you need just to play with different properties. So once we select and support one of the indexes for our pgvector implementation, then we will have this discussion. But right now, like, folks, if you already it's what we showed you today, it's already enough. to start prototyping and building on YugabyteDB. Stay tuned, because we are only going to improve our support for pgvector. It's not GA, it's early beta. We just let, because there were so many inquiries about it, we just let it out and we wanted people to experiment. But if you want to see how indexes work, just go to HNSW indexes, hierarchical navigable small world index, that is supported for Postgres as well. And there are wonderful articles. One of them is written by Chris. Chris works for Crunchy Data, and they create also excellent content about Postgres. You can Google for that pgvector HNSW in Postgres, and you highly likely will come across his article. But as for the live demo, we will show it a little bit later, not today.
Yeah, and it's good also to have feedback. We implemented that so that people can play with it, and then the feedback will be used.
Yeah,
and I see we have a comment from Bit SQL rules again, even with chat AI. Yeah, that's right.
Where is it? I didn't see it.
Yeah, on LinkedIn.
Yeah, for some reason I didn't see anything from.
With LinkedIn, we have to refresh the whole page to get the
Come on, seriously.
the messages. Yeah, I don't know exactly why, but we have to refresh. I will copy it here so that everybody.
Yeah. SQL rules got me like, yeah, SQL is simple, and that's another conversation. Like SQL can be simple, SQL can be advanced. It depends on your knowledge. It all depends on your use case. It's not difficult to write select star command from table and do the where clause. It's intuitive.
Yeah,
right?
yeah.
What's wrong with that? If you want something more advanced with recursions, window functions, you also can do this. But many other NoSQL databases, they would have hard time implementing this. And take a look, like MongoDB supported SQL interface for their Atlas offering. Cassandra always looked like SQL, and it's all over the place. Once those databases go mainstream, their users start asking for advanced querying capabilities, and those databases start implementing SQL. Just saying. All right. Thanks a lot. So yeah, we are already beyond the time. Thanks a lot for joining us, my friends. Hope you like this. If you're watching this recording, you can always find me and Frank on social media, on Slack. Give a try to this pgvector extension. Try to build applications, and never mind to bother us. Okay.
Great.
Yep. Bye-bye.